Hello, I'm Dr. Millicent Thomas. In this video, I would like to explain how to find the numerical representation for the statistical data what we collect. When we talk about the numerical description, there are various measures. We have the measure of center, measure of spread. Under the measure of center, we have the mean, median, and mode. Under the measure of spread, we have the quartiles, standard deviation, and variance. We can talk about the 5-number summary, and using the 5-number summary, we can construct a diagram called box plot. Another measurement, IQR, which is the interquartile range, and using those IQR, we can identify the outliers. But in this video, we would like to discuss only the first two, the measurement of the center and the measurement of the spread. And in my second video, part 2, I will explain how to get the 5-number summary, how to get the box plot, and what is IQR, and how to identify outliers using IQR. The first measurement for the measure of center is the mean. The mean is nothing but the arithmetic mean, which is also called as the arithmetic average. When we find the average, we add all the values and divide by the total number. If the numbers are represented by x1, x2, x3, etc., xn, you add them all and divide by n. Symbolically, you can use a Greek alphabet, sigma, to represent the sum of all those xi. You are adding all those xi and divide by n, and that is the formula to find the mean. The median is the midpoint of the distribution. When you find the midpoint, we have to always put that in proper order. Either put it in an ascending order or descending order. Then pick the middle term, and that will be the median. In this example, we have got two sets of results. One set of distribution has got odd number of values, 25 values, and the other one has got even number of values, 24 values. For the odd number, it is easy to pick the middle one because you'll have only one term, one middle term. So that middle term, 3.4, will be the median. When it is even, we'll get two middle terms. The average of those two, that is 3.3 plus 3.4 divided by 2, add them up, divide by 2, that 3.35 will be the median. Let's compare the mean and median. To understand this concept, let us see this simple example. Let us assume that we have got 5 values here in a distribution, 1, 2, 3, 4, and 5. The mean for this distribution is the sum of all this, 15, divided by 5, the total number, which is 3. The median is the middle term. It is already arranged in proper order. So the middle term is 3. In this case, the mean and median coincides. They are one and the same, and it is 3. Instead of this example, let us take another set of values, say 1, 2, 3, 4. Instead of 5, let us pick 5,000. So the mean in this case will be the total 5,000 plus 5,010 divided by the total number 5, and it is 1,002. The median is the middle term. Middle term is still 3. So the median does not get affected. Median is the same. But the mean, 1002, is almost close to, it is pulled towards the outlier 5000. If you are imagining that we are plotting these points on a horizontal line, 1, 2, 3, 4, say 5000 is in that extreme end, this mean is 1002 pulled towards that outlier, whereas the median does not get affected. So this diagram will give you a skewed diagram, right skewed, where the mean is pulled towards the outlier. On the other hand, if I have an outlier on the left side, the mean will be pulled towards this outlier. So in this case, your mean will be less than the median. If it is a symmetric distribution, the mean median coincides. For a right skewed, mean will be pulled towards the right. If it is left skewed, mean will be pulled towards the left. Let's take the same example here, which consists of odd number of terms. We saw that the middle term 3.4 is our median. So when these numbers are arranged in a proper line, we have picked the middle term, and that is our median. Once when the median is selected, we are left with two sets of data, one lying to the right of it and the other one lying to the left of it. And for these two items, it is easy to pick the middle term. Say the middle term for the left side is this, and the middle term for the right one is this. So these 3 points will divide the whole data into 4 equal parts, and that's why those 3 points are called the quartiles. This one is the first quartile, Q1. The median is the second quartile. We don't call that as Q2, we call that as just the median. This third point is our Q3, which is the third quartile. So in our example, after omitting this median, we have got two sets of values, one lying above and the other set lying below. For the lower one, the average of these two, 4.35, is a third quartile, and the average of the first set, which is the average of 21 and 23, middle point of the first set, which is the average of 21 and 23, 2.2, will be the first quartile. In this example, there are 18 measurements given. We are asked to find the median and the quartiles. First of all, when we find the median, we have to check whether this is put in proper order. Since it is not arranged in proper order, let us sort them out. The minimum is 41, so start with 41. It is put in an ascending order, 11 through 40. Everything is written clearly. So the middle term here will be the average of 26 and 27, because I have got two middle terms. So this 26.5 will be the median. Once when this 26.5 is picked, we have got two sets, one lying to the right of it, including the 27, and the other one lying to the left of it. The middle term for this is 33 and the middle term for this is 22. So this 22 becomes our first quartile, 33 becomes our third quartile. And the other measurement is the standard deviation. This is another measurement to find the spread. We have a formula. The standard deviation S is square root of sum of all xi minus x bar the whole squared and divide this by n minus 1. Let us try to understand what this standard deviation is. In this example, some 7 values are given. So my n, total number n of observation is 7. A sample of 7 is given. If I want to find x bar, I have to add all these 7 values and divide by 7. That may give you 1600. So that is your x bar. I'm trying to find the deviation of each values from this x bar. So that is my second column. Xi minus x bar. Some may be positive, some may be negative. So take the square of that so that everything becomes positive, even that negative and my positive values, everything becomes positive because square of negative is also positive. Add them up, you get 214,870. The standard deviation is the square root of the sum of xi minus x bar the whole squared divided by n minus 1. When you remove this radical sign, that becomes the standard deviation square. The standard deviation squared is the variance. So if we want to find the variance, we just add all those values and square them, square of all those values, divide by n minus 1. So in our case, the total was 214,870. N was 7, so divide by 6. This gives you 35,811.7, and that is your variance. The standard deviation will be the square root of that, which is 189.2. When the numbers are quite large, it is difficult for us to find the standard deviation or other calculation manually. So let us see whether we can use our graphing calculator to find these mean, median, quartiles, and standard deviation. Let's take the same example of those odd values, 25 values. First, let us enter all those values in our graphing calculator using our stat edit. Let us enter all those values under L1. Then select stat calc this time and pick one variable statistics. And if you're trying to calculate what that one variable statistics is, your calculator will give you these set of values. X bar, which is your mean, Sx, that's your standard deviation. And then when you use this arrow and go down, scroll down, you may find the minimum, Q1, median, Q3, and the maximum value in your calculator. So if we are applying TI 83 or 84, the keys are almost the same. The input is almost the same. It is easy for us to find all these measurements. The numerical representation of the statistical data can be easily obtained using our graphing calculator. So in this video, we talked about the numerical representation of the statistical data we have collected. We learned how to find the mean, median, which are the measurements of center. We also learned how to find the standard deviation and the quartiles, which are the measurement of spread. We learned how to do it manually, and also we learned how to use a graphing calculator to get these results. In my second video, I will explain how to find the box plot and also how to find the outlier using the numerical measurement IQR, which is the interquartile range. Hope this video was useful and hope you enjoyed this. Thank you. Thank you for watching.